to my today's session on the electromagnetic field, and in this session I will discuss some problems which are very important for the GATE or IES type of exam. Myself Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering of IARE. So, we will discuss the first question. Which among the following statements are precise in accordance to the distortionless line? A lossless line is also a distortionless line. This is the first one. Number 2 is that distortionless line is not necessarily a lossless line. So, we have to ask which statement is true. A is true and B is false. Second one is A is false but B is true. Both A and B are true and both A and B are false. So, what is the answer? Answer is the C, that both A and B are true. What is the explanation of this problem? The conductor in the lossless line are perfect and the dielectric medium that separates them are absolutely lossless. Though this condition is not practically possible, but for the lossless line means the dielectric medium that separates them, this is a line and this is a line, and the dielectric medium between them is absolutely lossless. A transmission line where the value of an attenuation is constant is independent of frequency and phase constant and linearly dependent on the frequency. Hence, it is obvious that a lossless line can also be a distortionless, as the distortion is depends, or the attenuation is depends on the frequency only. So, it can be lossless, but a distortionless line cannot be essentially a lossless line. So, both A and B are true. The current density produced by a magnetic vector A is equal to 2A phi in a cylindrical coordinate. We have to calculate the J. So, this is the vector magnetic potential. So, what is our first step? First step is the grad cross A. We have to calculate the grad cross A. So, if we calculate the grad cross A, and this is a cylindrical component, so what is the component? Del rho. So, first one is the rho phi or A rho A phi AZ. So, grad means del by del rho, rho del by del phi, and z del by del z. What is the A? A is only A phi component is there. 0, 2, 0 is equal to 1 by rho. So, if we calculate it, we can get the value of grad cross A. So, what is the grad cross A? Grad cross A is equal to B. B is equal to grad cross A. So, if we want to calculate it, 1 by rho. So, this is 0. This is 2 phi. So, if we calculate this B, after that what is the next step? Next step is we have to calculate the current density. What is current density according to the Ampere circuital law? Grad cross B from the Ampere or the Maxwell's equation. From the Maxwell's equation, we got J, current density J is equal to grad cross B. So, what will be the answer? If we solve this, we can get the answer. So, first one is the grad cross A, and after solving this, we are getting the grad cross A value is 2 rho A Z. 2 rho A Z. And what is J? J is equal to grad cross H is equal to, I wrote one small mistake, grad cross H is equal to J. So grad cross mu into B is equal to J. H means D by mu. So the value will come 2 mu naught rho square A rho. So answer C is the correct answer. 1 by mu naught grad by, if we put the value, we will get the question number 2. The magnetic field intensity produced at a distance rho from an infinite line or infinite cylindrical wire located along the z-axis is equal to 3 rho Fi. So what is given? The magnetic field intensity is given in the problem. What is the value of H? H is equal to, it is given 3 rho Fi. So what we have to calculate? The current density. Again, what is the current density? Grad cross H is equal to J. So this is the form of current density. So what we got here? Grad cross H into J means, again, A rho A phi A Z. 1 by rho, we are writing here rho Fi. First one is del by, we can write like this, del by del rho, 1 by rho del by del phi, del by del Z. What is the value of A? 3 rho. So this is the 3 rho. So Z, and A phi, it is with A phi. So 0, 3 rho into 0. So first one we are getting the value with respect to Z, it is 0. So we are not getting. If we do the second one is also 0. In the third one we are getting the value 3. So the value will come at the 3 rho in the arrow direction. So the current density will be 3 rho into the arrow direction. So again you take 1 by rho arrow, rho Fi Az, 3 rho Fi. Okay, it will actually in the problem. Okay, you can take that 3 arrow or something, no problem. So the magnetic flux density B and the magnetic vector potential A are related by B is equal to grad cross A. It is nothing but this is from the where capital A, what is capital A? Capital A is the vector, magnetic vector potential. So this is the relation, B is equal to grad cross A. We are moving to the question number 5. What is the question number 5? A magnetic material has the following parameters. M is equal to 120 ampere per meter and the mu has been given as the mu. The permeability is given as the 2 into 10 to the power minus 4 Henry per meter. B is equal to 200 microtesla. 200 micro means 10 to the power minus 6 Tesla. And XM is nothing but the magnetic susceptibility. What is XM? XM, or we can write it by the Xi M, is equal to magnetic susceptibility. And we know that we have to calculate the magnetic field intensity and magnetic flux density for both 1 and 2 case. So what is capital M? Capital M is nothing but the magnetic moment. Now for the first case, we can calculate the mu r is equal to mu by mu naught, or we can write that the mu r first. What is the relation of m? M is equal to mu r minus 1 into h. The magnetic moment is equal to mu r minus 1 into h, and we have to calculate the value of h. So what is h? M by mu r minus 1. So in the problem, mu r value is not given, but the value of mu has been given. What is mu? Mu is equal to mu naught into mu r. Mu naught value is constant 4 pi into 10 to the power minus 7. So keeping this value, we got mu r is equal to 15.91. So if we use this value, the m is equal to 120 minus 15.91 minus 15. So if we put minus 1, if we it is almost 15, so value will come at 8.048 ampere per meter in the first case. For the next case, B is given 200 microtesla. Microtesla is nothing but the 10 into 10 to the power minus 6 Tesla. Xm value is given as the 15. So we know B is equal to mu naught 1 plus xm into h. So what is h? H is equal to B by mu naught xm. So what is the B? B value we know. We know the B value. Mu r value we calculated. So if we mu naught value is also constant. So if we put all the value here, we will get the h. H is equal to 9.947 ampere per meter square. So in this formula, we have to need one important thing, the relation between the magnetic susceptibility with the magnetic momentum, and the relation is magnetic momentum m is equal to mu r minus 1 into h, and another relation is the magnetic susceptibility xm. Magnetic susceptibility xm, B is equal to flux density is equal to B mu naught 1 plus xm. So if we know these two formula, we can use this, we can solve this problem. Question number 5. Question number 6. A vector field B is equal to 4x square ax plus r xy square ay. We have to calculate the value of the magnetic field to at 1, 2, 3. What will be the value of r? So B value is given, and this is a magnetic field, and from the Maxwell's second equation we can write grad dot B is equal to 0 from the Maxwell's second equation. From the Maxwell's second equation, we can write grad dot B is equal to 0. What is the grad dot? Del by del x, because this is an ax and ay, plus del by del y dot. This is ax dot ax is y, so I am writing directly 4x square y minus r xy square equals to, and it is at the point of 1, 2, 3 is equal to 0. So what is the solve? 8xy minus 2r xy is equal to 2xy into r is equal to 0. So what is r? R is equal to 8xy by 2xy. So value of r will be the 4. Now, what question number 7? A phasor may be a scalar quantity or vector quantity. it is a time independent quantity, is a complex quantity. Which of the following is time dependent quantity, and a phasor is a complex quantity. Which of the above statements are correct? So, what is a phasor? Phasor means the pictorial description of any time depending quantity. So it is a time depending quantity. If anything is changing with the time, we can draw it in a pictorial diagram, and this is called the phasor. So first one is correct. It is a time dependent quantity. What is the second point? It may be a scalar or vector. Yes, if we think about the sound wave, it is a scalar quantity, but we can draw the phasor diagram. Similarly, we can draw the phasor diagram of an EMF, which is a vector quantity. So it may be a scalar and vector. It is a complex quantity. Is this correct or not? So while we are writing one equation, A is equal to sine theta or e to the power j theta. What is the meaning of the e to the power j theta? E to the power j theta is nothing but a phasor of a circle. If we want to draw a phasor of a circle, is equal to A is equal to e to the power j theta, and a to the power j theta is nothing but the sine theta plus j cos theta. So we can understand this is a complex quantity. This is a complex quantity. So all the three statements are correct. Here the answer is wrong. Actually the answer will be B. For a homogeneous and isotropic medium, if the electric potential is V, the Poisson's equation will be minus rho V by epsilon. How we can prove this? We know from first one, from the V, what is from the Gauss law, we can write grad cross E. What is this? Grad cross E is equal to, we can write like rho V by epsilon. We can write rho V into epsilon. Now what is the E and V? E is equal to minus grad dot V. What is E? E is nothing but the minus grad dot V. So we can write grad dot minus grad dot V is equal to rho V by epsilon. This is from the Maxwell's first equation. So grad dot minus grad dot V. So we can write minus grad square V is equal to rho V by epsilon. So grad square V, which is the Poisson's operator or Laplace operator, is equals to minus delta V by epsilon. So this is the question. B is the correct answer. We will move to the question number 9. Maxwell's equation is given. Grad dot D is equal to rho V becomes dash in the free space. Grad dot V is becomes 0 at the free space in a non-conducting medium. As we know that in a free space, the main conduction current means the current which flows in a conductor, or due to some external force or potential, current starts to flow. So the conduction current is 0. So conduction current is 0 means J is equal to 0. Current 0 means obviously charge, there is no charge. So the charge is 0. Charge is 0 means rho V. The rho V is equal to 0. And the Maxwell's equation grad dot D is equal to 0 for the if the free space is a non-conducting medium. Next we are moving to the question number 10. It is given as the grad A. A is nothing but the vector potential. A is kx square y plus y square zi plus 2 2xy square plus xz square j minus 12xyz minus 2xy square k is solenoidal. What is the value of the k? K means this k, not this k. This is the unit vector, so value is 1. So we have to calculate the value of k. So how to solve this problem? So it is solenoidal means the grad dot A is equal to 0. The solenoidal means grad dot A is equal to 0. So grad dot A means del by del x plus del by del y ay plus del by del z az. So if we differentiate the first one, 2kxy, y squared z is constant with respect to, it is constant with respect to y plus 4xy minus 12xy is equal to 0. So we got the value of k equals to 4. Next, a circular loop conductor having a radius of 10 centimeter. This is a 10 centimeter radius. So a circular loop having a radius of 10 centimeter placed in the xy plane. The loop consists of a resistance of 50 ohm. Shown in the figure. The B is given as, the flux density B is given as 2 sine 10 cube T Az. Find the current flowing in the loop. So we know the B. What is the A? A is equal to pi r square. And what is the radius? Radius is the 10 meter. So we got here pi or 100 pi meters. So what is flux? Flux is equal to d phi. Sorry, what is the flux? Flux is equal to B into A. So what we got here? 200 pi r square sine 10 to the power 3 into t. P value is 2. It is 100 pi. So 200 pi. So what is d phi by dt? D phi by dt is nothing but the rate of change of flux. So how much we will get? If you solve it, we can get the d phi by dt. And what is the d phi by dt? D phi by dt is equal to induced EMF E. So if we get the value of induced EMF E, what is the value of the current? Current is equal to E by R. So if we calculate the value of E by R, we can calculate the value of the current. Now we are moving to the question number 12. In a free region, sigma is equal to 0. The epsilon is equal to epsilon naught into epsilon r. Mu is equal to mu naught. H is equal to cos of 5 cos 10 to the power 11 t minus 4 y az. Determine the flux density D. So here the value of H is given. How to get the value of D? So what is the steps? The steps is, first we know grad cross H is equal to, H value is given in the problem. The value of H is given in the problem 5 cos 10 to the power 11 t minus 4 y. Now in the case of the if we use the Ampere circuital law in dielectric medium, what we get? Grad cross H is equal to, actually it is grad cross H is equal to J plus JC, but as this is a dielectric medium, so the conduction current is 0, so we can write grad cross H is equal to JC. JC is the conduction current. So grad cross H, we can solve it. Grad means del by del T. So del by del, if we solve it, we can get the value of the, we will get the value of the H. Now, we also know JC means the current density is nothing but the J means the omega into D. So from here, if we solve this equation, we can calculate the value of the D. If we solve this, we will get the value is A. In this problem, the B is given as 0.2 cos 120 pi t Az. The torque and the loop current is given, this is the torque, B is equal to 0.2 cos 120 pi t Az Tesla. The loop current is given as IT is equal to A sin 10 pi t into 10 to the power minus 3. We have to calculate the value of the current. So again, same type of problem. B is given as 0.2 cos 100 pi t. So this is a square. So what is the cross-sectional area? Cross-sectional area is 0.5 into 0.5. What is the meaning of the 0.5 into 0.5? 0.5 into 0.5 into 0.5 meters means 0.25 meters. So what is the value of the flux? The value of the flux is 0.2 cos 120 pi t into 0.25. We got the value of the flux. So what is the value of the induced EMF? Induced EMF is equal to d phi by dt. And what is the value of IT then? IT is equal to induced EMF by resistance. The resistance value is given as 500. So E by 500, and this equals to A sin 120 pi t into 10 to the power minus 3. So if we solve this equation, we can get the value of A. Question number 14. An electric field is given by E is equal to Z y square ax plus 2xyz ay plus y square z az. An increment path is represented by delta L 2ax plus 3ay plus 2az. Find the work done for a moving coil 4 microcoulomb charge along the incremental path if the location of the path is 2, 1, 1. So what is the problem? The incremental length is given. First we know the V is equal to minus E dot dl. E value is given here, and this is the dl, the incremental length value, and this is a dot product. So ax will be 1, ay into ay plus az into az. So we will get the value of the V. So the solution is also there. So W is equal to, so what is the work done? Work done is equal to Q into E dot L. E value is given, L value is given. So E dot dl we can easily solve. What is the value of Q? Q is given as the, what is the charge? 4 microcoulomb. So 4 into 10 to the power minus 6. So if we, after this calculation, we got this value. So the value we have to calculate at the point of 2, 1, 1, and if we put the value, we will get the value of the 56 picojoule. So the answer is C. So V value is given here. What is the E? So Z y square AX plus 2xy z az plus y square x az into 2ax minus 2ax plus 3ay plus 2az micrometer. Micrometer means 10 to the power minus 6. So if we solve it, we will get 2 minus 2z y square plus 6xyz plus 2 y square x into 10 to the power minus 6. Now, what is the work done? Work done is equal to minus, and all are the minus. EDL means everything is the minus. So, what is the work done? Q into V. Q value we know. What is the value of Q? Q is the 4 into 10 to the power minus 6. V value we got, and we have to calculate V at the point of 2, 1, 1. So 2, 1, 1 means minus 2 plus xyz means 2, 12 plus 2. So it is 12 into 10 to the power minus 6. Sorry, it is 1. It was 2y square x. Sorry, 2y square x. Okay, x value is 2. So it is coming 14 into 10 to the power 6. So what is the work done? 4 into 10 to the power minus 6 into 14 into 10 to the power minus 6. So it is coming 56 into 10 to the power minus 12. So minus 56 picofarad. A point charge plus 5 coulomb and minus 5 coulomb are located at 001. So two charge, it is plus 001 and minus 001. It is plus 5 microcoulomb. This is minus 5 microcoulomb. So what is the, calculate the dipole moment. What is the definition of the dipole moment? Dipole moment P is equal to Q into D. If the two charges are equal in magnitude but polarity wise opposite, and their dipole moment is equal to Q into distance between them. So distance between them is 2 unit. So what is the value? Q is equal to 5. 5 into 2 means it is 10 microcoulomb per meter. A dielectric is placed in a vacuum in an uniform electric field. E is equal to 10 volt per meter. What is the electric field intensity? The material if the relative permittivity of the dielectric material is 2. We know E is directly proportional to the 1 by epsilon. So it is, if it is 2, if the relative permittivity is 2, and for vacuum this is 10 volt, so it should be the 5 volt. A point charge 10 coulomb is placed at a point A in the free space. What is the intensity of the electrostatic field on the surface of a sphere of radius 4 cm at center? It is the easiest question. Q by 4 pi epsilon r square. What is the value of Q? Q value is 10 coulomb by 1 by 4 pi epsilon. They told it to take at 9 into 10 to the power 9. 9 into 10 to the power 9. And what is r square? R square is the 5 centimeter, means 25 into 10 to the power minus 4. Zero 0.4 is 3.6 into 10 to the power 5. So it will come 3600 volt per meter. When the currents are moving in the same direction in two conductors, the force will be always attractive force. What is the value of the current density J at 001 when the magnetic field intensity H is equal to y cos squared x plus y z? So again we will use the formula grad cross H is equal to J, and if we calculate this we will get the value. So again grad cross H is equal to J, and after integrating del by del x, del by del y plus del by del z, y cos 2x, there is no way y 0 and z, and if we put the value we will get ax minus az. So answer B is the correct answer. A vector of yax plus x plus z ay, we have to calculate the value of a rho at the point P minus 263. So what is the rho distance? Rho distance is x square plus y square. So value is 4 square plus 36 square is equal to 40. 5, as we can see, the equation tells is in an a rho. A rho is nothing but a cylindrical component. So phi is equal to tan inverse y by x and z is equal to 3. So if we put the value, we will get the value is minus 6 by 40. So in this session, we have discussed about the very important some questions from the GATE practice papers and the IES practice papers. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.